Nice introduction, and good morning or good afternoon, depending on your location around the world. Today, I want to give you a brief overview of ChemAxon Markush technology and the Chem Curator application. And later, I also want to give you a short live demo of the application and how it works. So, first of all, a little introduction of the topic. During drug discovery, there are a lot of points when you have a patent literature or patent-related question. In the early stage ID validation, the most important question, are the structure that you're working on are new compared to the prior art documents or not? And later, if you identify some promising compounds, you want to patent it, usually. And in this case, you want to formulating claims, and you need to know these claims are cover your structure series or not. And any of the claimed chemical space is covered by the competitor patents or not. And in the later phase, if you have a new compound ID, you need to know that the already filed patent is covered or not, or you need to file new patents. So the first question in the list, the structures are new or not. This is the field of the traditional search engines like STN or CFinder or things like that, where you can identify quite easily and check your compounds and check the novelty against the database. The following question needs a little bit more detailed analysis of the chemical space covered by the competitor's patent and your series. And our technology mainly can be useful in this stage to help to answer these questions. I don't think it's necessary to highlight the importance of the Markush structures, just a little reminder about it. So here you can see some impressive numbers about the 5 patents and how many of them contains Markush structures. In general, we can say every 8 patent contains some Markush claims. Obviously, these are not only chemical patents, but most of them chemical patents. And what is very important, these Markush claims are usually cover a very huge number of molecules, theoretically. So this chemical space can't be handled by enumerating all of them and searching them. You need some more sophisticated solutions to analyze this chemical space, because this size of compounds can't be handled with the standard chemical tools. Let's talk a little bit about the structure extraction and how can you make a computer understandable the structures, Markush and standard structures found in the patent documents. For this goal, we created the ChemCurator application. This is a computer-assisted structure extraction tool. You are able to load any kind of documents, including PDF documents, HTMLs, directly. You are able to load Google patents, for example, inside the tool. And after that, it's combined our naming technology, Markush representation, search, and visualization to help you to extract the necessary chemical information as fast as possible. How it works? As you can see, this is the compound extraction view of the application. In the compound extraction view, in the left-hand side, you can see the annotated document. You are able to load, as I mentioned, any kind of documents. Here, the tool automatically recognizes the chemical entities inside the document, highlight you, and after that, you are able to select them and simply drag and drop to the compound list in the right-hand side. So you are able to drag and drop any kind of compounds that you selected, or you can use some automatic extraction techniques, for example, extracting compounds by substructure criteria and things like that. The biggest benefit of the tool that you have a capability to modify or fix annotation errors or unrecognized structures and things like that. So this is not a completely automatic solution. This is a semi-automatic extraction where you can reach much higher quality at the end compared to the simple automatic extraction. The compound extraction view used by all of the users of ChemCurator, because this is very general, so everybody wants to see the exemplified structures and other structures mentioned in the document. More sophisticated use case, the extraction of the Markush structures from the document, for example, extraction from the claims. For this, we offer a separate view. We called it Markush extraction view. In the Markush extraction view, as you can see in the right-hand side, there is a hierarchic representation of the Markush structure. It works very similar like the compound extraction. So you are able to select the list of fragments, for example, in the annotated document, and that you are able to simply drag and drop these fragments to the extraction view. So you need some time to build up the Markush structure. However, after you build up the Markush structure, the tool offers some unique capabilities to analyze and work with it. For example, as you can see under the Markush structure, we have a list of exemplified structures. This list is continuously validated and checked against the Markush structure above it. So we are able to show you which one of the exemplified structures are matching to the Markush and which one is not. And in the case of matching, we can highlight you the corresponding part of the Markush structure. And what is more important and more unique, in the case of non-matching, we are able to highlight you the distinguishing features, why the Markush is not matching to your compound. We can highlight it both sides. We can show you in the exemplified structure, and we are also able to show you in the Markush structure where is the problematic part. So in this case, you are able to very simply double check, for example, your Markush extraction is correct or not, or you are able to modify your Markush structure. To this list, you are not only able to load the exemplified structures of the document itself, however, you are also able to load external compound list. For example, you can check your own compound series against the prior art Markush structure. Some words about our Markush representation and how it works. I strongly believe we have the greatest Markush representation on the market. So it technically covers all of the necessary features that it's required to represent complex patent Markush structure. So we support R groups, atom list, bond list, position variation, repeating units, homology groups. In the case of homology groups, you are also able to define constraints for the number of carbon atoms or branched knot, the alkane structure, for example, and things like that. So this is a quite smart and sophisticated representation and allows you to represent the Markush structure more or less the same way as is represented in the document. This made very simple to extraction and the comparison of the extracted structure with the original form in the document. Our Markush technology not only able to search the exact compounds against the Markush structure, but we are also able to enumerate them. Obviously, in the case of this huge patent Markush structure, the full enumeration is not practical. However, we are also able to do random enumeration that can be useful to give you a subset of the covered chemical space. As I mentioned, we have a very nice hit visualization technology and non-hit visualization. And as I mentioned, we have a specific editor for this complex Markush structure that's called Markush editor. This is included in the ChemCurator application, but also available as a standalone application if you want to use it. So these technologies are available in end-user application, as I mentioned, but you are also able to use some of them from 9, PyPI, Java, .NET API, or REST API. Before the live demo, I want to talk a little bit about the other side of the question list that I mentioned in the beginning. So one thing to analyzing the compounds that are already, and Markush structures that are already existing in the patent literature. Other thing, and maybe more important and more relevant, to create your claims and do it from the beginning. But before that, please let me show an example how it works in a practice. For example, I have a small patent claim here. Very important to highlight, we have absolutely no connection with this patent, so just randomly selected from the literature because it's relatively small, I choose them. So, as you can see, the first 22 claims I cancelled, and after that, the 23rd, it's a little small Markush structure, it's quite typical, so it has relatively simple scaffold, and after that, relatively short list of R group definitions. As I said, it's relatively short because it's only 2 pages or 2 slides in my computer. So I don't want you to read the full claim and understand it, just I want to give you example in this case, and show you the complexity of a simple claim. And as you can see, or if you check the document, you can see it contains 11 defined structures in the claim, besides the Markush structure, and it contains 67 structures in the description as examples. And here is an example, it's starting to claim 33. So my question is here, which one is structures are covered? Both of the, all of them from the exemplified structure list of the compound. All of them seems relatively similar. All of them contains the scaffold of the Markush structure. If we go back, you can see that. So, however, I'm quite sure not all of them is matching. If you do our Markush extraction and check the structures against the Markush, you are immediately see that 2 of them it's matching, but the middle one is not. If you check all of the structures, you will see 6 structures are not covered by the claim. And the tool not only able to show you which one is matching and which one is not, but we are also able to tell you why this is not matching. Our hit highlighting technology capable to highlight this metal group, it's not covered by the claim. And we can go to the details because all of the extracted information is linked to the original compound, and we can see we have this definition where the compounds, the claim says it can be an alkyl chain, the carbon chain connecting this other part, and this is the carbon chain, and the application not says anywhere that this carbon chain can be branched. So that's why this metal group is not covered. In this case, this is only a clarity problem with the application. So the compound itself mentioned into the following claims, but the claim 33 is not consistent with the claim 22. Claim 22 define a Markush structure that's not cover the specific structure claimed in the depending claim 33. So, how was I able to identify this inconsistency in the document? It was quite simple using our tools. So I used the did a Markush curation using Chem Curator. It was approximately 30 minutes for me using our tools. And I also extracted the exemplified structures from the document. Exemplified structures here was a form of images. I used ChemCurator together with our partner's application Clyde that is capable to recognize the image-based structures. And I did an analysis in ChemCurator. It was not more than 5 minutes. But the important point here, if somebody gives me 100 additional structure to check it against this patent, it required only additional 5 minutes. Because I already have the Markush structure as a computer understandable form, and from this point, checking any additional structures against this Markush is trivial. So this is the main benefit of the tool, because after you invest some time to create the Markush structure, you are able to very quickly and very effectively analyze compound list against it. It can be completely automatized. So, for example, we can offer an automatic system when you are able to upload the most important project-specific competitor patents, and the chemist can immediately check any structure IDs against the list, these high-quality extracted documents. So, as I mentioned, I also want to talk a little bit about the other side. How can you formulate your claims from the scratch? This is also a very important use case. The research group present you, for example, list of compounds, and they want to formulate a patent that covers the list of compounds. It's usually done completely manually. So you identify a scaffold, and after that you try to find some R group definitions, or tool can help in it. For example, we are able to automatically identify optimal scaffold, and after that we are able to automatically generate the corresponding R groups and the R group definitions. The big benefit of the tool, if you do it with our automatic technique, you are able to check your starting compounds against the created Markush structure, and during each modification that you do inside the Markush, you have immediate feedback about the structures that you wanted to cover. It's already covered, or you made some mistake and it's not covered. So finally, you get a very nice representation of your claim ID. However, this is a form of this structure, so this is not really useful for patent drafting. However, we have a solution for that. We call it to Markush to text, and Markush to text automatically generates a text representation of the original Markush. It not want to create a complete legally correct text. The goal here to create the list of the R group definitions that can be used for drafting your patent. So we want to avoid to make any mistake during the generation of the list. For example, if you miss some R group definitions, it can be a very expensive mistake. However, if you use the automatic generation, you have no chance to miss anything from the list. So the only thing that you need to care about to formulate the correct sentence around this R group definition list, but the chemical content of the list is generated and maintained by us. So some conclusion about this technology. We have tools to write better patents, and we have tools to understand your competitors' patents and to integrate the IT knowledge in your early stage drug discovery, as I mentioned, like an automatic check. And now, after the presentation, I also want to show you a little live demo how it works in the real application. Let's open the ChemCurator application. This is a Java-based desktop application, so you need to download and run your local computer, but the main benefit of this, there is no cloud component in it, so this is completely local and completely secure. Good starting point can be the demo project. You can find it under the Create New Project. create demo project. However, I already have an open demo project. I also want to highlight here, you are able to load different document formats to the application. Usually, the most beneficial to using some high quality XML document or HTML document, but you are also able to load PDF documents. Image-based PDF documents can be also loaded. However, usually the recognition capabilities in this case not so good. So I suggest you to use some high quality document instead of them. But now let's start with demo project. Let's open it. This is a patent document downloaded from Google Patents. The good news here that our Google Patents downloader use ChemAxon internal proxy server. That means, for example, some region, for example, in China where the Google applications not works, or Google Patents downloader still working and you can use it. So here you can see a document downloaded from Google Patents and annotated by the document, by our tool. As you can see, the image-based structures are also highlighted because I have installed Clyde application, the optical structure recognition tool that is capable to recognize image-based structures. Without Clyde, only the text-based information recognized inside the document. Let's go a little bit down, see you some, sorry, my scrolling is not working either. Go to meeting now. So let's find the exemplify structure list of the document. Here you can see some complex IUPAC names. As you can see, these IUPAC names are all recognized inside the document. The tool automatically finds them. And if you select any of these structures in the document, you can see the corresponding chemical structure immediately appears under that. You are able to modify it if you are not satisfied with the recognized structures, but in most cases it's not necessary because the recognition is very precise and complete. Obviously, you are able to select multiple compounds if you want. And how works the extraction itself? You are able to create a new compound list. Now we have an empty compound list, and you are able to select any of these structures and drag and drop them from the structure view. Obviously, multiple structures can be also selected together. And very important thing here, the tool maintains the two-way linking between the extracted information and the original document. That means if I select any of these compounds extracted from the document, you can see the tool immediately scrolling to the corresponding part of the document and highlights you. This is very useful if you want to double check your extracted compounds and the corresponding text around it, finding some assay information or anything else. It can be very useful, this scrolling. Obviously, extracting structures one by one and drag and dropping them, not practical in all cases. Sometimes the need to extract larger number of compounds, in this case, can be useful to use the extract structure from document function. This wizard can help you to extract the most important or relevant structures. For example, you can use a molar mass criteria. This is a simple filter that you can use to eliminate, for example, solvents and small molecule compounds. And something more sophisticated here, the substructure-based search. Let's use it and show it how it works. For example, in this case, I can say I'm looking for some specific scaffold, for example, and say, okay, I want to see this, but no matter for me, for example, carbon, nitrogen, oxygen in these positions. And also no matter for me the type of the bond here. So as you can see, we have a nice substructure query. And let's run this query against the document. And as you can see, the tool automatically recognized and extracted all of the compounds from the document matching to your criteria. Some of them from the irrelevant parts of the document. You can easily remove them by pressing delete. But these R's are coming from the exemplify structure section, so it seems to be relevant for me. You can easily go through the extracted compounds because all of them, as I mentioned previously, linked to the document. Remove what is not necessary or not interesting, and leave what is important. For example, these two is coming from the reference section, so I can also remove them. Very important, if you have a structure multiple times in the document, only the first occurrence extracted and linked. So if you have the same structure in some later part of the document, this is not linked and not duplicated during the extraction. This document also contains quite nice Markush structure. This Markush structure is also extracted and fully curated in the demo project. You can open it opening the claimed double-clicking on the claimed Markush structure node. And here you can see the scaffold of the document, and here you can see the corresponding fragment definitions. These fragments definitions are extracted very similar way as the compounds extracted previously, so you are able to select the corresponding definition and you are able to drag and drop it to the extraction view simply. Obviously, in the case of the Markush extraction, the tool not able to recognize all of the fragments sometimes and things like that. However, you are able to easily add additional definitions. For example, this structure, as you can see, not recognized because the tool was not able to recognize this fragment, but you are able to very easily fix the selection. In the fix annotation, you are able to do type things. For example, you are able to add here anything. Let's do some crazy, say benzene. Oh, sorry. Or you are able to link any kind of document, any kind of extracted structure here. So you are able to do first add the structure here. So nitrogen. Let's add R15 and 16. We have a new fragment definition, and I can say I want to link it to the document. So let's select the corresponding text. And now this structure is also added to the Markush structure. And this is the semi-automatic correction that I mentioned. So after the automatic extraction and automatic recognition, you are able to manually annotate things. And the most important part here that I mentioned in my presentation, the extracted Markush structure and the exemplified structure list under that are continuously checked. For example, as you can see, two of these exemplified structure, based on the tool highlighting, not matching to the Markush. And if you select any of these structures, you can see why this is not matching. So the tool says that this hydroxyl group in this position, not highlighted by black here, not mentioned in the Markush. The corresponding part of the Markush structure, also highlighted by red, and says in this position it's a nitrogen and no oxygen. So if you select the R group definition, you can see the extraction is correct because the claim exactly says it can be only a nitrogen in this position and no oxygen. However, we can try it. What happens if we add the missing definition? Let's say it can be a hydroxy group. And as you can see, the tool immediately revalidating the extracted compounds and says, no, it's matching because the hydroxy group cover the corresponding position of the original structure. So the compound extraction and Markush extraction works this way. So it's quite simple. Obviously, the Markush extraction needs some practice and it has some learning curve to understand the representation and to be able to extract the patent claims. However, I think this is very beneficial because after that you are able to do much more precise analysis of the Markush claims, and you are able to check a large number of compounds against this Markush. So that was that I wanted to present you today, and if you have some questions, I'm happy to answer them.